This video is on exercise 9C challenge questions of A-level Pure 2 textbook. Part A, we have y is equal to root sine root x. So here, the initial form looks very confusing, but if you write this in terms of the powers, you can rewrite this simply as sine of x to the power of a half, and the whole thing to the power of half again, because we have one bigger square root which covers everything, or which affects everything. And now, as you can see, the second way that we have written this function looks much simpler, and we've already seen so many examples in this form. Now let's differentiate this. So this is all about chain rule, and of course you can use the long form and the proper way of using the chain rule, where you use one, for example, you define one variable, let's say let u be equal to x to the power of a half, and so on. But we can just use the quicker version that in all my videos I've been using that. So first we start by differentiating inside. Remember, first you differentiate the inside, then you differentiate this as a whole function, and then you differentiate this as the last bit, because you are basically doing three differentiations. So first, x to the power of a half differentiates to a half x to the power of minus a half. So it's a very standard differentiation, times, now sine of this thing, whatever it is. So we know that sine differentiates to cos. So we just write cos of x to the power of a half. This is a very standard differentiation. So when you have sine of 2k, for example, this differentiates to 2 cos 2k. So what you do is that you first differentiate the inside, and that comes out. Then you differentiate this specific trigonometric function. In this case, this is sine, and sine differentiates to cos. And then you just, again, write whatever you had inside the brackets. And this is exactly what's going on. So you first differentiate the inner function, which the derivative is, its derivative is half x to the minus half. And then you basically sine differentiates to cos, so you write this in this way. But we haven't done yet, because now we need to use that type of chain rule. If you remember, let's say when we have something like 2x plus 1 to the power of a 2, then we differentiate this in this way. So first we differentiate inside. 2x plus 1 differentiates to 2, and then these times the power comes down times whatever you have inside to the power minus 1. So 2 minus 1 is just 1. So that's how we differentiate this type of functions. And in this case, as I told you, we have kind of three differentiations. Now the third differentiation is that this whole thing to the power of a half. So of course a half comes down, and then we just need to write this bracket again. So sine of x to the power of half, and the power minus 1, which is minus a half, which is exactly the same as here. So now we've done all the differentiations, and we can simplify this. So even though the question hasn't stated anything regarding the final form of the answer, we can simplify this. So we are going to have, so this cos x to the power of a half is in the numerator. Now we should be careful, because we have a half here and a half here. So half times a half is a fourth. So we will definitely have a 4 in the denominator. And we also have this x to the minus a half. But since this is, the power is negative, so when we have this in the denominator, the power turns positive. So we have 4x to the power of a half, and the last term is this. And again, the power is negative, so we can send this to the, write this in the denominator, and the power changes to positive, which is going to be sine of x to the half to the power of a half again. Now we can simplify this again, or write this in a form that makes more sense. So we can write this as cos of a square root of x over 4x 4 root x times root sine root x, and as the final form we can write this as cos root x over 4. So root x times root sine root x is root x sine root x, and that's it. So the thing about this question is that the question is not something that you haven't seen before, but I mean a new technique that you haven't seen before, that's what I'm saying. But the thing is, it's very, very easy to make a very, even, very, very slight mistake in questions like this. And then, that leads to get a wrong answer. So that's the challenge in this question. So as long as you know what to differentiate and how to differentiate, then the rest is just going to be the matter of the accuracy. So that's part A. Now let's do part B. Right, we have the natural log of y is equal to sine 3x plus 4 cubed, because these 3 just means that, let's just write it down. So then y is equal to sine 3x plus 4. Now the whole thing to the power of 3. So, it's very important to notice this, because this is going to be helpful. And I suggest you to, when you see something in this form, it's better to write this in this form, because when you want to differentiate that, the second, form makes more sense. Right. So here, if you notice, we have the natural log on the left-hand side, which means if we do e to the power of, for example, the left-hand side, then the natural one will be gone, so we will only have y. So let's do that. Let's do e to the power of both sides. So we will have e to the power of ln y is equal to e to the power of sine 3x plus 4 cubed. Now here we are going to have y is equal to e to the power of sine 3x plus 4 cubed. Right. Now, hopefully you can remember that whenever we have e to the power of any function, then the derivative is simply equal to f dash x e to the fx, which means the derivative of the power times e times basically the function times the y. In this case is e to the f of x. So you simply need to differentiate the power and then times e to the f of x. Which means in this case we need to differentiate this, and then the answer, the derivative dy dx, will be the derivative of this times e to this power. So now we need to differentiate this. Dy dx is equal to. Okay, so differentiating this is actually very simple, because in the previous question we even had a more complicated version of this type of differentiation. So this question, in my opinion, is even easier than the previous one. So first we can start by differentiating inside. So 3x plus 4 differentiates to 3 times. Now we have the derivative of this specific function, so which is cos, and then this 3x plus 4. Now we have one more differentiation, because now it's the time to treat this as a function, which is just a function to the power of 3. So 3 comes down times this whole function, but with the power 3 minus 1, which is 2. So sine 3x plus 4 to the power of 2, and times e to the power of sine 3x plus 4. So please don't forget that, especially when we have functions like this, that the derivative is actually something very long. When you write that down, it's very easy to forget to write e to the power of that function again. And that's it. So even if you want to simplify this, there's not much to do other than multiplying these two numbers. So you can do 3 times 3 is 9, 9 cos 3x plus 4 times sine, or you can write this in the usual way like this. So sine squared 3x plus 4, and then finally times e to the power of sine cubed 3x plus 4. And that's it. So this one was easier, and because you only have one differentiation, you just need to remember a multiple of things, and that's it. Whereas in the previous one, we had to differentiate several things, if that makes sense. And even the functions were a bit complicated, since we had fractional powers, but here I think the numbers are a lot better. So that's it for this video, and thanks for watching. Please subscribe for more videos, and good luck.